right, everything looks to check out. So here we go. Just an opening question. On which section is the spinner most likely to land? And hopefully this is not rocket science, but it should land mostly on 5. So section 5. Now why? Because it has the largest area. So on which section is the spinner least likely to land? It looks like section 3 and 4, because these have the smallest area. So, which which section is the spinner most likely to land? In this case, any. They all seem to have the same amount of area. So in which section is the spinner least likely to land? Same thing, any, because they all have the same amount of area. So when we look at this, what we want to do is we want to understand how the probability of an event indicates its likelihood. And our criteria then is I can identify possible outcomes of an experiment. I can use probability and relative frequency to describe the likelihood of an event. And I can use relative frequency to make predictions. Now, out of that, there's a lot of words that we're going to need to define. So here we go. I forgot to do my defining sheet. Good thing I'm doing this right now. And grab this and snag this, and there we go. I'll polish this up this summer because not great videoing right now, but oh well. All right. Lock that. All right. An experiment. That's the first word that we need to know. We're doing an experiment. An experiment is an investigation or a procedure that has varying results. The possible results of an experiment are called outcomes. A collection of one or more outcomes is an event. And the outcomes of a specific event are called favorable outcomes. These are new words that their definitions should be thought over. I'm going to show you the example of an experiment, and then we're going to talk about the events and the favorable outcomes. So, here's an event. An event, choosing a purple marble. Choosing a purple marble. That's an event. The number of favorable outcomes, there's one, because there's one purple marble. Choose a red marble. Well, the number of favorable outcomes is 1, because there's one red marble. Choose a green marble. The number of favorable outcomes is 2, because there's 2 green marbles. Choose a blue marble. The number of favorable outcomes is 1, because there's one blue marble. Choose a yellow marble. The number of favorable outcomes is, again, 1, because there's one yellow marble. So let's make a little bit more complicated of an example. How many possible outcomes are there? If we look, when we say how many, that's a counting question. I want you guys to see that because there's going to be a difference. How many, and then what are, and then how many. And how many is asking you for a number. So how many possible outcomes are there? There's 6. What are the favorable outcomes of spinning an even number? Those are the numbers 2 and 4. It didn't say how many, it said what are they? In how many ways? So in how many ways, there should be an S there, and I'm not going to fix that yet. Can spinning a number less than 2 occur? So this is a number less than 2. There's 1, 2, 3. There are 3 ones on that spinner. So there's 3 ways that we could spin a number less than 2. So we've seen favorable outcomes, we've seen events, and what we want to do is we want to think about, is that going to happen, or how likely is it going to happen? So the probability of an event is a number that represents the likelihood that the event will occur. Probabilities are between 0 and 1, including 0 and 1. The only things that are impossible are things that have a probability of 0. The only things that are equally as likely as not are things that are at 50% probability. The only things that are certain are things that have a probability of 1. Everything else falls into either the likely category, between 50% and 100, or the unlikely category, between 0 and 50. Let's look at this. There's an 80% chance of rain, a 50% chance of thunderstorms, and a 15% chance of hail tomorrow. Describe the likelihood of each event. Well, the likelihood that there's rain, because 80% is greater than 50%, we would say that this is likely. There are thunderstorms tomorrow. Well, 50% chance of thunderstorms is the same as 50%. And so since it is 50%, it's equally likely as unlikely. And the chance that there's hail tomorrow is 15%. Well, 15% is less than 50%. And so that means that it's unlikely. We have one more definition. When you conduct an experiment, the relative frequency of an event is the fraction or percent of the time that the event occurs. So we have relative frequency, we have a formula, equals the number of times the event occurs, and then the total number of times you conduct the experiment. By the way, I might abbreviate this from time to time as rel frequency. So RELFREQ. So just want to make sure that you know that. All right, you flip a bottle and record the number of times it lands upright and the number of times it lands on its side. Describe the likelihood that the bottle lands upright on your next flip. Now, normally, this is all you get as a question. I broke this down to help you think through it. First thing that might be helpful to find is how many times the bottle was flipped. So if we count, we've got 1, 2, 3, 4. 4 groups of 5 is 20, and then 22, 23, well, 21, 22, 23, 24, 25. So the bottle was flipped 25 times. How many times did the bottle land upright? 2. Find the relative frequency of when the bottle lands upright. So the event of landing upright happened twice out of all the possible times that we flipped the bottle. So we want to describe the likelihood. Good thing we just took a test on changing fractions into decimals and percents. 2 divided by 25 is 0.08 times 100 is 8%. And because 8% is less than 50%, we say that this is unlikely. One more problem. Each turn in a game, you randomly draw a token from a bag and replace it. The table shows the number of times you draw each token. The question will be, how many times can you expect to draw a positive point value in 35 turns? Now again, I broke this down into 3 parts so that you guys can think it through a little bit easier. In your homework, these will not be broken down. So when you're asked about finding the likelihood of something, and you're given a relative, and you have to deal with relative frequency, you need to find the number of all the outcomes and the number of times that specific event occurred. So find the times a number of times a positive point is drawn. So positive points are both 3 and 1. So we have 1, 2, 3, so that's 15, plus 2 is 17. So a positive point is drawn 17 times. Find the number of times a token is drawn altogether. So 17, then 18, 19, 20. So how many times can you expect to draw a positive point value in 35 turns? So what we do is we stop and we look. 17 divided by 20. Now, if we actually, I'm going to do this a little bit differently now that I'm thinking this through. Couple different ways we could do this. Method number 1 is we can go the positive points and total draws, and we could go 75 over 20, or sorry, 17 over 20 equals 17 divided by 20, which gives you 0.85, which gives you 85%. And so we would expect a positive, if this continues, we would expect a positive token drawn 85% of the time. So what we could do is we could say, what is 85% of 35? In which case we can then go 0.85 times 35. And 0.85 times 35 gives you 29.75. So we could then say about 30 times. If this had been 29.4, we would say about 29 times. Now, I want to show you an alternate method that works as well, but I think you might need to be a little bit more careful with this one. This one explains a lot of detail as to what's going on. It explains how in 35 turns, how likely the event is of occurring. On the other hand, if we just set up a proportion of positive outcomes to, well, positive tokens to total tokens, and then we say we don't know how many positives we're going to get, and 35, this too will give us the same answer that we're looking for. Because 17 times 35 is 595, and that equals 20x, and we divide both sides by 20, and that's going to again give us 29.75. Now, what I will argue with you is that the second way works. It's possibly faster, but there's less understanding as to what's going on. It's a valid way, but it takes more intuition to recognize that this is a correct method. So, if you look at option one takes you through the actual finding the probability, using the probability to find your answer. Option number 2 says, well, 17/20ths is a probability. It's just not looking like one. And so therefore, we've got this relative frequency. We haven't put it on the table. We haven't thought about what it means, and then we just run with it. So number 2, that method is great, but it needs to be done with some actual thought and understanding of what's going on. So with that, I think that's it. Yep, that is. So you should be equipped enough to attempt your homework. Thank you.